Alright, hey there. I realize that in all the videos I've been making over the years, I've never made a video on 3D printing. And I do a lecture on it in my Engineering CSE 101 class at Clark, but I've never done a video about it. So I thought I would do a short video introduction to 3D printing. So here's my 3D printer running right now. It's printing something that we're going to redesign later. But most printers that work by adding layers of filament are basically this design. So you have a spool of plastic. It looks like, you know, thick fishing line or what you put in a weed whacker, and it goes through a little mechanism that pushes it through this tube. It goes into this device, which has a heating element which gets heated to around 200 degrees Celsius, melts the plastic, and then the plastic just comes out of a little nozzle. It's pretty hard to see from here. I can show it to you later. And it gets deposited onto this print bed surface, and the print bed slowly moves down. This moves back and forth in two directions, and it constructs an object by assembling layers one on top of the other. So if you don't already have access to a 3D printer, or you don't use one regularly, one of the first questions that comes up is, what do I need a 3D printer for? And the truth is, you don't need a 3D printer in the same way that you don't actually need a car, or a dishwasher, or a washer and dryer, or a microwave oven. You can get by without those things. There's public transportation. You can boil water on a stovetop for 10 minutes to make your tea, and so on. But if you have access to those pieces of equipment, they make your life a lot easier. And that's the way 3D printing has been for me. Having the ability to design and manufacture whatever I want in, a few minutes, instead of looking for it, buying it, waiting for it to be delivered, and so on, has been a real game changer for me. So let me just give you a few examples. So just as an example, most people seem to like liquid soap these days. I still like good old-fashioned bar soap, but most modern sinks don't have a place for a bar of soap to rest in. So made a little 3D printed soap dish, and you can put the soap there, and it's sloped on the inside, and it's got a drain hole so that if water comes off the soap, it drains out through that nozzle. We also use some round soap sometimes from Sapo Mills, and so I made a round soap holder. And same thing, the top comes off, the inside is sloped, and if you put your soap down and there's water on your hands, the water just pours out through the nozzle, so it doesn't sit inside the dish and get all nasty and stuff. Does that change my life? No. Could I buy a soap dish? Sure. But it took maybe an hour to design these things, print them. You can print them in whatever color you like, and you've got soap dishes made specifically to fit whatever brand of soap you're using. Or maybe you have an old dresser and the door pulls have fallen off. You can design and 3D print your own door pull. Somebody else had designed a Thomas face, so put that on top, painted it up, and now this dresser drawer is usable again. Again, not a live or die situation, but this took a few minutes to do, and it's kind of fun. Kind of funny thing happened a few years ago. I took a drawing class and I ordered a bunch of pencils from Amazon, and then not too long ago I needed more pencils, and so I reordered them from Amazon. And when you go on Amazon, there's an option sometimes for purchase again, so I just hit the purchase again button to reorder a box of number 2 pencils. What I forgot at the time was that I had previously responded to a school supply drive for a school back east, was looking for supplies for their kids, and I bought a box on Amazon for them that had a number of supplies, including pencils, but the pencils that they requested were these beginner pencils, and when you look at these things, they're really, really big, and it seemed kind of odd at the time, but it turned out everybody in the house really likes using these. They're fun to hold and so on. But once the eraser wears out, you can't put these little eraser toppers on top because they're too big. So, pretty easy project. Just 3D printed an adapter. So this goes on top of the pencil, and then the eraser goes on top of the adapter, and now we have, you know, big wide pencils with replaceable erasers on the top. So that was a cool little project. Maybe you build projects and you need boxes to put them in. So I printed this project box that I could put this printed circuit board in, and the front of it slides off like that, and then I can slide the whole thing out, or I can put it back in and close it up like that. So those are just some examples of things that you can do that, yeah, you could do these, you know, other ways you could live without being able to do these, but if you have the ability to 3D print, you start realizing all kinds of things that you could do that that will make your life a little easier. Again, here's the 3D printer. There's the control screen. You can see that it's heating. It's saying the hotbed is at 37 degrees and slowly coming up, and then the hot end will start to increase in temperature, and then it'll start printing. The way this is set up, basically this platform up here can move up and down, this head can move left, right, and this bar can move forward and backward. Again, material's coming out of here. It goes through this mechanism that pushes it into this tube. This is called a Bowden tube. The plastic comes into this part of the structure, and that's what's called a hot end. The hot end looks like this. It has two wires going into a heating element which heats up this block on the bottom. There's something called a heat break. It's a little physical separation between the heating up block and this heat sink. And then in the bottom you put in a nozzle which looks like one of these, and that's the thing that the filament actually gets squeezed through, that causes a very, very fine diameter, about 0.4 millimeters of filament to come through. Alright, so let's take a look at the CAD software that you use for doing 3D printing, and most people are using TinkerCad. It's free software that is web-based. If you don't have an account, you can sign up for it, and it's the usual drill. Put in your email address and get a confirmation email and so on. It's completely free to use. Your designs get stored in the cloud, and it's also very collaborative. If you want, you can publish your designs, you can look at other people's designs. So there's tutorials you can go through, but the easiest way to learn TinkerCad is just trial and error. Just get in there and start messing around with it. The one thing I will say is you really, really want a mouse, preferably a mouse with a scroll wheel. Don't try to do TinkerCAD with a touchpad. I've tried to do this. I've watched numerous people try to do it. It is really frustrating. It can be done, but it's a whole lot easier if you actually have a mouse. So I've already got an account. I'm logged in through Google. I'm going to go to Designs, and I'm going to say Create 3D Design. And when you do this, it will pick a silly pronounceable name at random for you. So I'm going to change the name to Box with Lid. And let's just make a small box that we can put things in. So mostly you have these shapes over here on the right, and if you just, you know, left click and release one, you can drag it into the plane wherever you want it. Just left click again and it will drop it. And so you can take different shapes and put them in here. And you know, you can change the color if you want this to be yellow, and so on and so forth. And if you've ever done anything with PowerPoint or Visio or anything like that, this works very much the same way as far as changing the shapes and dimensions of objects. So for example, I've got a little half sphere here. I can grab a corner and I can make it elongated, or I can make it just bigger. This little place I can click and drag at the top controls the height, and this little arrow I can use to lift it off the surface or bring it into the surface. There's also these little curved arrows that I can use to rotate. So if I click this arrow, I can rotate this object. So for rotating, you click and hold. I can rotate this object to any angle that I want. And if I stay inside this blue circle, I can rotate in steps. If I go outside, I can rotate to any angle that I choose. It took me a long time to figure that out. So you can stay inside. So I can rotate in that direction. I can rotate, out of the plane, and so on and so forth. And you can move it up and so on. So I'm changing my view once in a while. And there's a few button commands I can use for this. I don't memorize these. It's just muscle memory at this point. But basically, if I click and hold the left mouse button on the surface, that's how I can select objects. So I can draw boxes around objects. If I click and hold the right mouse button, I can move my viewpoint, right? So I can tilt the plane in different directions. If I click and hold the scroll wheel, I can just move the thing in my field of view. If I just use the scroll wheel, I can zoom in and out. And so that combination lets you sort of get to whichever objects you want. If I left click on an object and release, it selects it again. I can go ahead and I can change dimensions and so on. I can also click somewhere in the object other than one of those drag points, and I can move the whole object around. So that's our basic mechanism for putting shapes onto here and manipulating those shapes. Alright, well, we can put shapes down and we can move them around and we can change their dimensions and their shape and so on. So what do we do with that? Well, a really important concept in 3D design is the role of negative space. If you've ever done a dance class or an art class, painting and such, you understand negative space is as important as positive space. So what is negative space? It's the absence of stuff. It's the holes. So for example, I can take this cone and I can put it over here on top of this ellipsoid, and I could say, let's group these together. So here's my group button. So I just drew a box around the two of these to select them. I've got two shapes. I can hit the group button and they get merged into a single object. But I can Control Z to undo that. If I take this cone and I say, instead of making it a solid purple, let's make it a hole, and now I select these two objects and I shape them, I group them together, I have my ellipsoid with a hole cut in the middle. And that's how we take stuff away from objects, is by grouping it with holes. So that's a really powerful thing that we can do, and we're going to use that to create a little box that we can put stuff in, a little box with a lid. So I'm just going to Control A to select everything here, and I'm going to hit the delete key to delete all those objects. And let's go ahead and make a box. So I'm going to start with a polygon, and I'm going to make this, I don't know, I'll just eyeball it and make it look, roughly symmetric. So this is going to be my starting shape. And the first thing I'm going to do is hollow this out on the inside. So I've got this selected. I'm going to hit Control C to make a copy, and then I'm going to click over here and hit Control V to paste. Now I can drag this over, and I'm going to change the dimensions of this a little bit. Actually, let me do something first. Let me make this thing, let me make these dimensions easier to work with. So I'll make this 33. Alright, so I'm going to copy this, I'm going to Control V it, bring it over here, and I'm going to change this into a hole. So if I look at the dimensions of this, it's 38 by 33. Alright, I'm going to hollow out the inside of this original shape. So I'm going to take, let's say, 3 millimeters off of each dimension. So instead of 38, I'm going to make this 35, and instead of 33, I'm going to make this 30. And now I want to take this and I want to center it in here so I can hollow it out. Well, I'm just going to select both of these objects, and I'm going to use this alignment tool. And I'm going to say, let's align the middles and let's align it up and down. And so now this should be, a piece of hole centered on the original material. Now if I select these and I group them, I get, a nice box, but there's no bottom on it. So let me Control Z that, and let me click that middle section and just raise it up. And you can see on the right it says 0.00, there's 1, there's 2, there's 3. So now this is raised 3 millimeters above the work plane. I'm going to select both of these, group them, and now I've got a hollow little box. So that's going to be the inside of this thing. Now I want to make a lid for this box. So we're going to do some more playing with negative space here. Let me start off, let me Control C and Control V to make a copy of this. And I'm going to ungroup it. So if I click this, the selected object will be ungrouped, and there's a hierarchy. So if I group things multiple times, each time I ungroup it undoes one of those groupings. So I'll ungroup that. And let me take this middle section, this hole, and pull that out for a moment. And so this polygon is the exact same dimensions in XY as the box itself. So I'm just going to shrink this down and make this like 3 millimeters in height. So this would sit on top of here perfectly. So I want to add a little lip to the inside. So let me go ahead and flip this over. It should be symmetric, but I don't know that for sure. So let me flip it over so I'm actually working with the part that's going to face down inside this box. And let me take this hole and turn it back into something solid, and I'll make it yellow. And so this, you know, would sit exactly on top of that. And let me flip this over too. So this would sit exactly on top of this. But what I want to do is I want to make this shorter. So I'm only going to make this about 3 millimeters. And I'm going to make it a little smaller than this, right? So the this should fit exactly the inside of this box. I can also take off my perspective by hitting this button over here, and now I have a non-perspective view. So this should fit exactly in the inside of this box, right? But if I put that on my lid, it's going to be too tight of a fit. I need to make this slightly smaller so that it actually goes inside the walls of this box. So I'm going to change this by half a millimeter. So I'm going to make this 29.5, and I'm going to make this 34.5. And I was using my tab key there to switch from one window to another. Anytime you can use keyboard shortcuts, do it, because mousing is inherently inefficient. So let me go ahead and make this about 3 millimeters. And so, you know, it's the same size as same thickness as our lid, and this is already sitting 3 millimeters off the platform because it started off as that hole inside. So if I were to take these two objects and align them, right, now I've got a lid that should, you know, fit right inside this this box. But let me make this a little cleaner. Let me go ahead and select this inner piece, and let me change it to a hole. And let's make the dimensions of this a little smaller. So let's go down to 31.5 and 26.5. And now let's take the three of these and align them. And this hole, I would like this inner hole to be 3 millimeters off the platform. So like that. Nope. Alright, let me make it a little taller. Alright, so now if I group these three objects together, I should get a nice lid that theoretically will fit directly inside this object. And so that's what we're going to print. So how do we do this printing? I'm going to print both of these at the same time, so I'm just going to say export. Now if I wanted to print just one of these, like the lid, I could select it and say export, and it'll say, hey, do you want to include the selected shape or everything in the design? But I'm going to do everything, so I'm just going to go like this and say export. We want to export as an STL file. That's what our software is going to work with. And then you have to pick a place for it. So I have a directory set aside for 3D printing designs, and it takes a little while when you first do this for it to get things ready to export. So I'm just going to put this in a file called box with lid, and what that's going to do is create a an STL file. And if I were to look at this, it's not human readable, right? It's a binary file that has instructions about how to create about what this object looks like, but that's different from knowing how to control a 3D printer to actually create this object, right? The STL file is a description of this object, where the shapes are and so on and so forth, but we still need to convert that into instructions that will control a 3D printer. So we can go ahead and print this, but let me make one more change to this just for fun. Let's go ahead and add a little handle to this lid. So I'm going to select this lid and I'm going to rotate it 180 degrees like that. And now I'm going to take a ball, and I don't know how big to make this. I'll just try like 8 by 8. And we'll make the height 8 also. And now let's pick both of these objects and align them. And now I'm going to take that ball and raise it up. And I need it to stay in contact with the lid, but I want it to be mostly out of the surface so I have a good area to grab onto. So that looks pretty good. So let me go ahead and group these together. I don't have to group them, but I'll do that just for fun. And so now let's re-export this, and I'm going to put these objects pretty close together so that I don't spend a lot of time on the printer moving from one object to the other. Keep them pretty close. I won't select anything. I'll say export STL file, and we'll let it prepare, and I'll go back to box with a lid. Alright, so now I've got my STL file, and as I said, that basically has a description of the object itself, but we need to change that into instructions that the 3D printer can use. So we need what's called a slicer, and a really popular slicer is called Cura, C-U-R-A, and I'm going to go ahead and run that. This is more free software. And it seems to be well supported, and it does a really good job of taking this description of the file and turning it into instructions for the printer. So I'm running version 5.5.0. I'm on Linux, by the way, so your version numbers and interactions may look different if you're on something else like Windows. So I'm going to let this come up, and this is basically showing me a model of my print surface. And I've already set it up ahead of time for my printer, which is called the Seriality Ender 5. It's about a 5-year-old printer. I'm using PLA, which is a type of plastic that you can feed into a 3D printer. And I'm mostly using standard setups. I changed this a little bit. I added a build plate adhesion of brim, which just puts a little extra material around the object that's being printed. It helps it stick to the print surface a little better. So I'm going to go ahead, I'm just going to take my file and I'm going to drag it into my print area here, and there's a picture of my object, and I'm going to say slice. And it will tell me it's going to take about 53 minutes to print, and then if I hit the print button, it'll go ahead and print this for me. Now, one detail here, this lid is missing material underneath it, right? It begins with this little outline area sitting on the surface, and there's a few millimeters of that outline that get printed before it starts printing this red surface. And normally we would want to build some supports under that, so we can't print over open space. But for just a few millimeters in such a small object, I'm going to go ahead and try and print this exactly as it is. And if this didn't work, then I would want to go in here and I would want to go to support, and I want to say go ahead and generate support, and I can specify what that support should look like, what pattern it should use, and so on. But we're just going to live dangerously and print it out like this. So I'm going to say preview, and it will show me what it's going to do layer by layer. So it's 100 layers. This is what the first layer will look like. So it's just going to be, you know, that brim in turquoise, and then the beginning of the actual object in yellow. And as it goes through each layer, it starts filling in, you know, the material that's going to fill in the solid space, because it doesn't want to print solid materials in plastic. It's going to make a little honeycomb pattern here, and then it'll eventually cover that with a solid layer. So that's the bottom of the box, and then it starts building up the walls, and you can see the lid has a little honeycomb structure inside also. And then at layer 74, the lid will be done, but it'll still be printing the rest of the box up through layer 100. And this is all, you know, stuff that that the slicing software Cura has figured out. So to actually print this, let me go back to my main menu here. So to actually print this, I could take the output from the slicer and put it on a little SD card and put that into the printer, and it could print from there. But I'm going to use something called Octopi. So octopi.local, and this is free software that you can get. It runs on a Raspberry Pi, and you can basically hook your Pi up to the printer, and it will let you do things like send files, send commands, monitor the printer. I can look at, you know, the current temperature of the print bed and the hot end, and I can see what's being sent to and received from the printer, and so on. And I've got a camera set up also, so I can watch this as it prints. And so I'm going to go back to my slicer, Cura, and I'm just going to say print with Octoprint. And it's going to go ahead and send the information over to the printer. And so the first thing it's going to do is heat up. So it's going to set a target temperature for the bed, the surface that it prints on, of 60 degrees, and it's starting to heat that up. And I can see my graph over here. This blue line on top is 60 degrees. That's what it's trying to get to. And this line that's starting to creep up, that's the actual temperature. Once that happens, it'll set the hot end temperature, target of 185 Celsius, and then it'll slowly raise that temperature up. And once that's done, it will start actually doing the printing. So I can look at the terminal, and I can see it's sending me, you know, the bed temperature is 22.9, 23, 24, and so on. The hot end temperature is about 9 degrees Celsius. It's in the garage. It's pretty cold. So it's heating up, and eventually it'll go ahead and start printing. Alright, so the printer has just started printing. It draws a little line down here to sort of, you know, get the nozzle started, and now it's drawing the outline of the first layer, which is going to be that brim, which it's making around the actual objects we're trying to print, just for extra adhesion. And it's basically just, you know, pushing filament through the tube, squeezing it out of the nozzle, and depositing it on the plate. The plate is heated to about 60 degrees Celsius, which helps it adhere. There's a cooling fan here which cools the top part of that hot end to let the filament stay cool as it's going through the tube, and then it melts basically in the nozzle at the bottom of the assembly, and that's basically what it does. So you can see the head end's at 185, the bed's at 60, and it's doing its thing. One general comment here, really don't ever leave your 3D printer running by itself. It's good technology. This is a high quality printer, but you know, I've had cheaper printers in the past that one of them had under spec connectors in the main board, and over time they started to melt, and after they melted too much, eventually the main line coming in shorted out, and it smelled bad, and it smoked a little, and then it burned itself out. But you know, Got a fire extinguisher nearby, just in case. And it's one of these things you don't want to like leave the house with your printer running. When I was growing up, you know, we just kind of had this rule: we would never leave the house if the clothes dryer was still running. We would stop it before we left. Probably it wouldn't have never been a problem. It was just something we did, right? Well, kind of the same way with a 3D printer. You really want to be around and nearby when it's printing, just as a safety measure, because, you know, 185 degrees Celsius, that's pretty hot. There's lots of built-in checks. If the end starts getting too hot, it'll shut it down and so on and so forth. But, you know, you never know. So I can actually monitor the print from here. I can look at the actual code that's being interpreted to drive the printer itself, so I can watch where it's actually depositing fabric, and that little green dot is the current hot end position. Or I can just go straight to the camera and watch it like that. And if something goes wonky, if the object being printed detaches from the surface and starts moving around, I'll be able to see that, and I can go ahead and stop the print and avoid wasting too much material. I'm also printing with a time-lapse setup, so after it's done printing, I'll show you a video of the entire print process. Now, it's going to take about 50 minutes to print, and that'll turn into a pretty short video, and so that can be fun to watch. So we'll let that print, we'll come back and see how it looks. So the print is finished, and here's just that little, you know, line that it puts out to start the whole print process. And here's the actual thing that we had printed, and we can lift that off with a little putty knife, and there it is. And you can see on the bottom there's the opening in the lid, and this outer portion is just the brim that was used to anchor it to the print surface, and we'll peel that off and we should have a nice little box. Alright, so we can take this and it'll just peel off. It's actually pretty fun to remove. And so there's the box, and there's the lid, and we should be able to put the lid on the box, and then you can take it off, and you can put whatever you want in there. So that's a basic run through of 3D printing from first design to finished product. There's usually a little bit of cleanup. I had some issues with my printer recently with the cooling system, and so I've been adjusting it and making some tweaks to some of the settings. So I've still got a little bit of these stray pieces of material that'll come out, but they clean up pretty easily. I have a hot air gun I can use for the tricky ones, but mostly you can just scrape off the little imperfections, and there you go. So that's a quick top to bottom run through of 3D printing. Hope you enjoyed. Thanks.